So far we have been doing Newton's laws for reasonably simple questions, right? So we didn't follow any structure to solving the problem. We just took a problem, looked at the free body diagram and then tried to basically write equations and solve. But if you're looking at reasonably tricky questions, that is slightly more harder questions, you will find that from slightly harder questions to very, very hard questions, you need 7 steps, and these are the only set of 7 steps. Every Newton's law question ultimately has 7 steps. Even the questions that we have done so far, we may not have broken it up into 7 steps, but there are these 7 steps. Now, what are these 7 steps, and to understand them, let us start with an example. So here I have 2 blocks connected by 3 pulleys. Okay, there is one rope that is going this way, there's one more rope that goes there, and of course there's a third rope just connecting the 5 kg block. Now I want to find the accelerations of 8 kg and 5 kg. I'll assume g is 10 meters per second square like usual. Okay, now how do I solve this problem? Let us do step by step. So you will see that you have to do these 7 steps in order. Okay, in this order. Let's see why. First, what is the first step? Choose and draw the bodies. Now choosing the bodies, you may think that's very silly, but choosing the body is very important. Like, do I draw the rope? Do I leave the rope? Do I draw this support? In many cases, choose the bodies that move and don't make these bodies look like this when you're drawing. Give enough space and draw. So my first step itself is quite important. Here it may look like it's a very easy step, but as we go on, you will find that this also can become reasonably tricky in a difficult question. Okay, so each of these steps will be of great importance in different questions. Now all steps may not be equally important in all questions, but please do go through these steps. So this is our body, 8 kg body, and then I'm going to draw this 5 kg body here. So draw them as they look. Don't tilt them, don't change their orientation, don't flip it around, don't make the 5 kg here, 8 kg there, 5 kg below. Don't do all that. Draw it as they are. Okay. Then the next step, second step is a very, very important step, free body diagram. You know this already. What does that mean? That basically says draw the bodies separately and mark all the forces on them. We have already drawn the bodies. Now when we are drawing all the forces, please remember that if this tension is T or if that tension is T, that means this tension is T. These are all massless ropes. This tension is T. And if this is T and this is T, this tension is 2T. Now why is that 2T? Because I have not drawn the free body diagram. I must know that for a massless pulley, if this tension and that tension both are TT, then this must, if suppose I call this T1, you know that M is 0. So that means T1 minus 2T is mass of the pulley, which is 0 into A, which is anyway 0, right? So that means T1 must be equal to 2T. So you never write T1 and 2T. We will just directly write this as 2T if this is a massless pulley. If the pulley had mass, then you'll have to do this carefully. Then if the pulley had mass, that will also be part of your free body diagram. So do you see that the first step, should I put the pulley or should I not put the pulley? Have you already figured out that this is TT, 2T? If you have, leave the pulley, don't draw the pulley. If not, please do draw the pulley also, because if the pulley has mass, then you have to draw the free body diagram for the pulley as well. So that means you need to choose the bodies, you have to choose the pulley in that case. Of course, in this case, I am not choosing the pulley. Now I know this is T, this is T, this is 2T, TT, 2T. Now this is 2T, this rope will have the same tension 2T. So this is 2T, this is 2T, right? And if I now look at this 8 kg block, this 8 kg block is going to have one force which is mg, 8 into 10, that is 80 newtons. And then it is going to have one tension force upwards, 2T, and another tension force here which is T. This T pulls this block and pulls that block. It also pulls the pulley downwards. So you can't ask what is the direction of tension, but you can ask what is the direction of tension force on 8 kg block. What is the direction of this tension force on 8 kg block? So this is 2T and that is T. Similarly, for the 5 kg block, let us look at the 5 kg block. There is a force of 2T acting upwards, and there is a force of mg which is 50 newtons acting downwards. Now have I marked all the forces on these blocks? Yes, right? Nothing else. So that means I've completed the second step, which is the free body diagram. Now please don't think too hard about the free body diagram. Don't bring your intuition. Don't try to guess what the forces should be. You should be able to say, like for example, if you thought this force must be equal to that force, this tension must, don't try all that. Do the calculation, mark the forces, don't think too much about it. Is that clear? The less you think in step 2, the better it is for you. There is a step for you to do a lot of thinking, that is step 4. Okay, but don't do this kind of thinking in step 2. We will see particularly sometimes what happens is in this step, people like to think they understand forces and mark a lot of extra stuff. Here of course it was straightforward, but in other problems, particularly when you have 2 blocks pushing, people feel like whatever I am pushing here must basically act on that block. All of that turns out to be extremely dangerous. It will make lots of mistakes. Okay, therefore just do the forces and mark the forces as they are. Don't make any guesses. Okay, now the third step, this is an important step. Because you are going to solve equations, you want to reduce the number of variables. I have already assumed a variable here, t. I don't know what t is. 50 and 80 of course I know. If these masses were not given in terms of 5 and 8 but was m to m, I'll still know mg because m is given. But t is something I assumed, so it is not given, right? Now if you look at this block, I'm going to get one equation which is net force on this block is mass into acceleration. So I'm going to get one equation for this fellow, plus I will get one more equation for this fellow. So how many equations will I get? I will get 2 equations. With 2 equations, how many variables can you solve for? 2. You know that if I have 2 equations, x and y, I can solve for x and y. With 1 equation, I can solve for x. With 3 equations, I can solve for x, y, z. So with 2 equations, you can maximum solve for 2 variables. But one variable is already done. One variable is t. So that means I'm only allowed one more variable, right? So 2 equations minus the number of variables that have already been used up in the free body diagram. So minus 1 used means 1 variable allowed. So if 1 variable is allowed, that means you're only allowed to use A. You're not allowed to use B. So you can use one acceleration called A. But you see, I have to write net force for this guy is 8 times A1 and net force for this is 5 times A2. But you're not allowed 2 variables because the third step is telling me that if you use 2 variables, you will not be able to solve. Because you already have 2 unknowns, A1, A2, and you have T, you have 3 variables, but you have only 2 equations. So what do? You are only allowed 1 acceleration. So let me assume that this guy's acceleration is A. You have to find this 5 kg block's acceleration in terms of A. You are not allowed any more variables. So I need to find this, and that is my job in step 4. Step 3 tells me how many variables are allowed. In this problem, we are only allowed 1 variable because we already used up 1 variable for t. In another problem, like we will probably do next, you will see that you may be allowed 2 variables, but you may actually need 4 variables, but you're only allowed 2. So in which case, using these 2, you have to find the other 2. So are you allowed A, or are you allowed A and B, or are you allowed A, B, C? Sometimes you're not allowed anything. Okay, we'll come to such a question. But at this point, we are allowed 1 variable. And so what is the 4th step? Find all accelerations in terms of the allowed variables. Okay, use your intuition, do all your thinking here. And this is where we are going to use freeze and slack. Okay, constraint motion. So now this is A, I have to find what that is. But that's exactly what we spent so much time doing. If this guy goes up A, there is a slack of A, there is a slack of A, you have done this now enough. So A, let me take this slack that way. So that means there is a slack of A here. And to get rid of the slack, I'll pull this down by A. When I pull this down by A, I'll get a slack of A here and a slack of A there. So if I take this slack and that slack, how much slack do I have? I have 3A. But then I have to pull this guy down. But I have 3A and I have nothing there. What do? Cut the slack into 2 pieces. 3A by 2, 3A by 2. Now I have got 2 slacks, and of course that is connected, you can't do anything about it that side. But now since I have got 3a by 2, 3a by 2, I will pull it down by 3a by 2. So this guy goes down 3a by 2. So that means this slack and that slack has been removed. So notice, in terms of a, I have got the acceleration of the 5 kg block. So this is 3a by 2. Now I can write 2 equations. Now if you come to step 5, it says choose the axis along the acceleration direction. So that means here I'll choose it like this. Here also I'll choose it like this or like that, doesn't matter. But you're not going to choose it horizontal, you're not going to choose it at an angle. Obviously you wouldn't have even done that in this problem. But that is because all forces and accelerations are in one direction in this case, one dimension. Well, this is a one-dimensional motion problem. Things are all moving up and down, all forces are vertical. So it was very simple, you really didn't have to do step number 5. Imagine a slightly harder question. Imagine that you have an inclined plane. So if you have an inclined plane, there is one force acting vertical, there is a normal force acting at some other angle. Now what direction will you resolve? Along the direction of the acceleration. Acceleration is a very good axis to choose. But that's one axis. So if my acceleration is in this direction, this forms one axis. Perpendicular to the acceleration forms another axis. Because you have selected accelerations in step 4, you can choose the axis in step 5. In this case, of course, I don't have to do anything because it's all nice, it's already selected for me. Right? It's already in this direction. Now step 6, let us write net forces mass into acceleration. So I'm going to write that here. So first, remember, you should always start with MA first. I've said that earlier. Again, let me repeat. Whenever you're writing net force is mass into acceleration, start with MA first. Because MA tells you the direction of acceleration. It also tells you the axis. So that means you can find net force along A. And also please do not try to solve the first equation. Write all the equations one below the other. So let me start with this guy, 8 kg block. MA, 8A. What direction is it? Upwards. So I will take upwards as positive for solving this particular, writing the equation for this guy. So since upwards is positive because A is positive, I have written it like that. 3t upwards minus 80. So I will write it as 3t minus 80. Not 80 minus 3t, 3t minus 80. Why should I write 3t minus 80? Because I wrote MA first. So MA, A's direction, you want to write net force along the direction of acceleration. Newton's second law is not just net force is mass into acceleration, it is net force in the direction of acceleration is mass into acceleration, or net force is equal to mass into acceleration, and acceleration direction and net force direction must match. So acceleration direction and net force direction we are matching. If I had written 80 minus 3t, I should remember to put a minus 8a. Most people forget to do that. Therefore, it's a good idea to start by writing MA first, then choose what to do. Now let us go to the second block. So if I look at this, this is 5 times 3a by 2, 5 times 3a by 2. In what direction is that? Downwards. Therefore, I won't write 2t minus 50. Downwards is my positive. So I will write 50 minus 2t. Notice that there is a flip that is happening. We have done it enough times, so you know this. Right? 50 minus 2t. Now I have got two equations, t and a, two variables we can solve. Of course, before we solve, we have to multiply, etc. and solve it. So I hope it's clear that once you write it this way, many times you can just add, other times you just need to do some multiplication and then add. What do I want? I want acceleration. Well, if I want acceleration, let's get rid of t. If I multiply this by 2, and multiply this equation by 3, then you can see that this will be 60 and this will be 60, they will cancel. So I don't need to worry. This is 150, that is minus 160. So 150 minus 160 is minus 10. Let me repeat, this is 150 because 3 into 50, that is 160. So 150 minus 160, minus 10. The 60 here and the 60 there got cancelled. And let us now look at this case. So I have 16 here, and here I have 15 into 3, 45 by 2. So I have 16 plus 45 by 2 times A. How much is this? This is 32 plus 45. So 32 plus 45 is 77, right? So this is 77 by 2. You bring the 2 up there, you will get 20 by 77. And so if I combine all that, I am going to get A is minus 20 by 77 meters per second square. Let us think about it. I assumed that the 8 kg block was moving up. But the answer seems to tell me the 8 kg block is moving down. Why? Because if I assumed it to be A up and the answer shows minus, it means this guy is actually moving down at 20 by 77 meters per second square. Now the last step says solve, which we have done, and then there is a small thing here, focus on the question. If the question had asked me for this guy's acceleration, fine. Maybe the question asked me for acceleration of 5 kg block. Is the answer this? No, right? Then you have to go back and substitute. Suppose the question had said acceleration of 5 kg block. After you finish, go back and look at what the question actually is asking. Maybe the question did not ask you for acceleration of 8 kg block. If it asked you for acceleration of 5 kg block, remember it is 3a by 2 downwards. So it is 3 by 2 into 20 by 77 upwards. Why? Because I should have a minus sign and I should say downwards. So it is this much upwards. And so if I cancel that out, I'm going to get 30 by 77 meters per second square upwards. So you also have to think about what is the question that is asked and then find the answer for that. Particularly in questions like this where you'll have A, you'll have 3a by 2, 2a, you'll have many different things. So for example, this tension may have been asked. Maybe that tension was asked. If that tension was asked, you solve for T, good. But if this tension was asked and you found T, remember that answer is 2T. It's a simple thing, but usually people lose marks unnecessarily for that. After you solve, go back, look at the question, you solve for something, question asks you something else, see whether you can find what is asked. So let me repeat these 7 steps, and these 7 steps are important to do in this order. I will go through these steps again carefully. First you choose and draw bodies. Only if I did that, then I can draw the forces on the body. So obviously I have to do that before I can draw the forces on the body. So once I do that, mark all the forces on the body, use as few variables as you can. If you can use T and repeat 2T, etc., do that. Then the next step. Each body is going to give you either one equation or sometimes 2 equations, sometimes 3 equations. For example, if this body could have had forces in that direction, you might have had net force in the horizontal direction is mass into acceleration, one equation. Net force in the vertical direction is mass into acceleration, another equation. So you might get 2 equations with each body. In this case, of course, you will get only one equation, because if you write this equation, you will get 0 equals 0, which is not very useful, right? So how many equations do you get? Comes from the free body diagram, which means if you want to do step 3, you should have done step 2, correct? So that's why that is step 2 and this is step 3. So now, if you know how many equations you are going to get, and you look at the free body diagram, you will say how many unknowns are there that you have already used up. Okay, so used variables like T are unknowns that are already there, which means equations will give you the number of variables you can solve for, but already some variables you have assumed as forces. So that will tell you how many variables you are allowed. Like in this case, I was only allowed one variable, right? Which means you are not allowed to choose any more variables. So don't say A1, A2, A3. Choose A, because only one was allowed in this case. That means it is telling you now, hey, find out what the other acceleration is in terms of A. The question is actually being posed to you. Then it is useful because you can then start searching and saying, oh, okay, if this is A, what should that be? How will I go about finding this? That's up to you. That's why you have your brain. Okay, so you can use freeze and slat, you can think, you can just assume, do lots of things. This part is entirely up to you. The first 3, don't think. The last 3 steps, don't think. Okay, so only think in step 4. Step 4 is your step. The others, the first 3 belong to Newton, last 3 belong to Newton. Okay. 4th step is yours. So think of it like that. So once you connect these two accelerations, which actually is what you do in 4th step, that means you know all the accelerations, directions, etc., at least in terms of variables, which means you know which directions you have a by 2, 3a by 2, etc. That becomes the axis. Now all the forces may or may not be in that direction, in which case you have to resolve forces, which hopefully you know what to do there. So you resolve. In many problems, one-dimensional motion problems, you don't have to resolve because it's already resolved. In other cases, you need to resolve. Then once you have done step 5, then you go and start writing Newton's laws, which is step 6. Write the laws, right? Net force is mass into acceleration, one below the other. Always start with ma, because then along this direction, for example, in this case, 8a, this was an upward direction equation, whereas that equation is downward direction equation. So I hope that is clear. So once you have written this, then you can go about solving. And finally, after you have solved, please do look at what the question asks. So let us do one more example just to get a better understanding of what we are doing. So then you can see how these 7 steps work in many different situations. That is something that you can do by solving many problems. Let us go for one more example. Now let us look at this question. So in this question, there is an inclined wedge. This is fixed. Okay, so this is a fixed wedge. There is a block of mass 2m, it's frictionless, all surfaces are smooth, massless pulleys, massless ropes, etc. There is a block of 2m connected to a pulley, and there is a rope that goes that way, and that rope is connected to a projection like that from the inclined wedge, so that part can't move. And then the rope goes around like this. This is a movable pulley. And again, this is connected to one portion on the wedge and the other one from which hangs mass m. Question is, what is the acceleration of mass m? Now, first thing is we need to do all our 7 steps here. So let us do it very carefully. So first step is to choose our bodies. What are the bodies that are going to really matter? 2m and m. Will these pulleys matter? Well, they are massless pulleys, so I don't want to worry about them. In fact, the only thing I need to know about the pulley is if this was T, this is T, that must be 2T, which I will directly do. Okay, but right now let us just first write down draw the 2 blocks. Let us look at how they look. They look like this, right? Without changing the orientation, draw the blocks. So look at how block M looks. It looks like this, vertical. So I'm drawing block M like that. Now this 2M, it is tilted this way. When you draw, keep the orientation this way. Don't try to straighten it. You will find that if you straighten it, you will end up in lots of trouble. So let us keep the 2M block as it is looking right now. Keep the orientation as it is. Draw big blocks and separate them, give enough gaps. Don't draw them very close to each other, because then your forces will start to hit each other and collapse, right? So is this clear? We have chosen the bodies and then we have drawn the bodies. Second step, free body diagram. What does that mean? All forces that act on this block. Now I know that there is an mg that acts on this fellow. Since m is given in the question, I will continue to use it as mg. We can substitute for g later. At this point, I'll just call it mg. And then here, this guy has a force of 2 mg, gravitational force of 2 mg. Are these the only forces acting? No, right? Because if there is a tension T here, the tension here is also T, because this is one single rope. But if these two sides have tension T, what about that? 2T. Because that's a massless pulley, TT downwards, 2T upwards. Basically must give me net force 0. This is 2T, that must be 2T. But if this is 2T, this whole thing is one rope. So that means this is 2T. So what is the tension here? 4T. And it is acting along the incline. So let us mark it carefully like that. A force of 4T. All forces over or something left? Well, it's on an incline. So there must be a normal force that is acting this way. So let us mark N. So have I marked all the forces? This force, gravitational force, normal force. mg, T. So we have marked all the forces. Clear? How many equations will I get now? I'll get one equation. Well, I have not marked on this, sorry. I have not yet marked this force. I started with T, but I didn't mark it here. So this is T. I'll get one equation for this block. I will get two equations for that block. Why two equations? One along this and one along that. One along the horizontal and one along the vertical, right? So horizontal, vertical, you will get two equations. So you will get two equations, whether you're going to take it along the incline and perpendicular to the incline, or you're going to take it vertical and horizontal, doesn't matter, that's up to you. So you'll get two equations here and one equation there. So you're going to get totally three equations. So I have three equations. How many unknowns are there already on this diagram? T is unknown, but 4T and T are the same unknown. N is a new unknown. Mg is not an unknown because M is known. Okay, because if it's given in the question, answer is expected in terms of M. So this is known, known, unknown, unknown. So how many unknowns? Two unknowns. So two variables have been used up, which means 3 minus 2, one variable is allowed, which basically means what? You're only allowed A. You can't say B. So something you have to choose as A. I could choose this as A, I could choose that as A. We started T here, so let us start with A here. Why up? Because for freeze and slack, moving things up is easier. So I'm going to make A go up. So I'm going to say this guy's acceleration is A in that direction. Wait a minute. Couldn't it also move like this? Couldn't it also move like that? No. Along the incline, you know that the normal force will make sure that this block does not go inside, but will also make sure it doesn't fly off. So you know that this block has to move along the incline, which means you also know that in this direction acceleration is 0. You needed three equations, which means three accelerations, one variable, one acceleration. We do know already it is 0 meters per second square along the perpendicular to A. Now that is step 4. Find all accelerations. Some of the accelerations are just 0, but find them. It is 0, right? That's still something that you found. What is this big discovery? It may not even look like a discovery to you, but it is important to say that this fellow is only moving along the plane. It is not moving along this direction. Therefore, the acceleration is 0. Now, this is a fixed wedge. If this wedge was also moving, then you will not be able to conclude that it has 0 acceleration like that, because it would have an acceleration like this plus like that. So it would have a component in that direction. Because it is a fixed wedge, you could have directly resolved mg sin theta, mg cos theta. I have not done that. But with fixed wedges, you know that beforehand, that you can resolve. But the moment the inclined wedge is moving, then it's not at all clear that you should resolve mg first. Sometimes it's actually good to resolve n. Sometimes it's good to resolve mg. And you don't know what to do unless you get to step 5. That's why I have not yet resolved in this case. Though actually for such cases where it is fixed, I will start off by drawing two forces instead of drawing one force. But let us keep this as it is. Now let us say that this acceleration was A. We should use freeze and slack to find out that acceleration. Well, if this moves up A, how much is the slack? A. Grab the pulley, lift it up, A, A. Don't look at the T. Grab the pulley, lift it up, A, A. 2A, 2A. Pull the pulley down by 2A, 2A, 2A. Now this is not going anywhere. So 2A plus 2A, 4A. So this guy goes down 4A. So this fellow's acceleration is 4A. Interestingly, that is 4T and that was A. This is T and this is 4A. There is a nice connection. This connection we will later see has something to do with work. The work done by tension on this fellow will turn out to be this 4T into the displacement that you are making, and the work done by tension on this fellow will be T into 4A with a negative sign because they are in opposite direction. The total work done by the tension force must be 0, and that's basically why 4T and A, T and 4A, that connection is something that we should generally look for. If you find it, you should feel happy that something is right. Anyway, that's not important right now. What I want you to keep in mind is we calculated this was 4T, we also found out that it was A and 4A. So have we found all the accelerations in terms of A? Yes, just one variable is allowed. So step 4 is done. This step is where your creativity must be at the maximum. Before this, don't think. After this, don't think. Now just let's do it systematically. We have to choose the axis. This guy's axis is already chosen. Are all the forces along the axis? Yes. Now let us look at this. The acceleration direction is like that and like this. So I must have all forces along this direction or this direction. What about this force? Already along this. What about N? Already along the perpendicular direction. What about 2 mg? We need to resolve. Now this and this angle, you know that if this angle is 30 degrees and I basically take the horizontal and make it vertical, then along the incline will become perpendicular to the incline. You know this angle is 30 degrees. We have done this enough times. So the angle between 2 mg and N, or one of the axes, is theta, which is 30 degrees. So that means 2 mg in this direction is 2 mg cos 30. Cos 30 is root 3 by 2. And in this direction it is 2 mg sin 30. Sin 30 is half. When you do that, please destroy the 2 mg. You can't say 2 mg, this and that will be double counting. 2 mg is what has been replaced by these two forces. Now can you see that we have done step 5 and we have resolved forces along the acceleration. Many problems you don't need to because the force is already resolved. Like 40 was already resolved. If everything was already resolved, step 5 you can skip. But in a really tough question, you will have to do the resolution. So therefore, you should be sure about what to do there. Now, what is step 6? Write Newton's laws. But the trick involved in writing Newton's laws, always start with MA first. I am going to write the equation that I am not going to use much. In this direction, what is the acceleration? 0. So 2m into 0, right, is 0. 2m into 0 is 0. In that direction, so in that direction, what is the net force? N minus root 3 mg. This will help me solve for N. Let's look at the question. Does it ask you for N? No. So if I wanted to find N, I will use that equation. Let me just leave that equation and go on to the other two equations. Let us now look at the equation along this direction. 2ma in that direction. 4t minus, so it is 4t minus, look at this, 4t is along the direction of A, but 2 mg into half, which is mg, is along the opposite direction, so minus mg. This mg comes from the fact that it is 2 mg into half. Half is sin 30. So 2 mg sin 30 was mg. Okay? Because the angle was given as sin 30, some other angle, you will obviously get a different answer. Now let us, so basically two equations are done. Now shall we go to the two equations? One equation for this. This fellow doesn't have two equations, this fellow has one equation. So what do I write? M into 4a. M into 4a, so I will write it as 4ma, mass into acceleration downwards. So I should write mg minus t. I really don't need this equation. I need only these two equations. If I just add it straight away, mg gets cancelled. But that is not useful, right? I want to find a. So I should actually cancel out t. How will I do that? I will multiply this by 4. And now if I add, this 4t and that 4t cancels. Always solve equations by eliminating. Don't try to substitute. Don't write 4t is equal to mg plus 2ma and then substitute. It's a big mess. Try to see if you can cancel it out by elimination. Anyway, so once I have cancelled 4t, this is 4mg, that was mg minus mg. So together it is 3mg. And then when I add these two, remember what am I going to get here? 16ma plus 2ma, 18ma. So if I cancel out the m, I get A is equal to, once I cancel out the m, I'm going to get A is equal to 3g by 18 or g by 6. Now we can feel happy about whether we have found the answer. Is that the step? We have solved, we found A. Happy? No, wait. Step 7 was solved. Then think about the question. What was the question? Question said find acceleration of m. What is A? Acceleration of 2m. What do I want? I want acceleration of m. But acceleration of m is 4a. Not a, it is 4a. So it is 4 times g by 6. And so this is 2g by 3. If I take g as 10, acceleration of m turns out to be 2g by 3 or 20 by 3 meters per second square. Always remember that you must find whatever was asked. So after you have solved, there is a little bit left. Go back, look at what was asked. This was what was asked. Your variable was assumed for 2m, but the question was asked for m. So therefore make sure that after you solve, go back, read the question and look at whether you are really answering the question that is asked. It's a silly point, but you make a mistake and suddenly you have lost all the marks. All the effort you put into solving goes for a toss just because you didn't do that one last step. Okay, so can we look at this quickly? What I'm going to explain now is these 7 steps. Why are they in this order? We have already seen. But let us work backwards and see. Ultimately, what do you want to do? You want to answer the question, for which you need to solve. So that means solving and answering the question is the last thing you want to do, right? To do that, what do you need? You need equations. What equations? Newton's laws. F net is mass into acceleration. So you have to write these equations. So before you solve, you need to write equations, which is net force is mass into acceleration. That's why that is the 6th step and this is the 7th step. Now, before I write net force is mass into acceleration, I need to know the forces resolved along some axis. What axis? A axis. That is why I need the axis and resolution. I also need the acceleration. So that means step 4 and step 5. I need the acceleration before I can resolve, because acceleration tells me what direction to resolve, right? So that means to write F net you need the axis and resolution, and to do the axis and resolution you need the acceleration. So step 4 has to be all the accelerations, step 5 has to be the resolution. Then using these two you will be able to do step 6, which is to write all the equations, which is net forces mass into acceleration. Okay, but how many variables are you allowed? Well, how many equations can you write? That many variables are allowed, but some variables would have gone into the free body diagram as forces. That means only the remaining variables are allowed. So to write all accelerations and you wrote it well, you should make sure that you have used no more than allowed variables. Exactly the right number of variables, which basically means you should know how many variables are allowed. But that comes straight from step 3, because you know how many equations are going to be written by looking at the free body, and you know how many variables are already used in the free body, which means before you can do step 3, what should you do? Well, you have to do the free body. And to draw the free body, you must have the bodies, no? So that is step 1. So do you understand why this is a very, very tight set of systems? You need to follow this entire set of 7 steps. You keep doing it repeatedly. As you learn, you will find that it becomes extremely easy to master and do any kind of Newton's law problem.